Hello, my name is Bahati Abdul Karim, and I'm going to take you through A-level applied mathematics, specifically the Trapezium Rule. It's suitable for students who are doing mathematics, Senior 5 and Senior 6. The Trapezium Rule is used for estimating an integral area under a curve of a continuous function over a given interval AB. Take an example. If you have your function y is equal to f of x, and then the area under that curve can be got by integrating the function from a point A to a point B with respect to x. As you can see, this is our function. So if you want to use calculus, then you can integrate the area under this function. You can integrate this function and you'll get the area under this function. But rather, if we are to approximate that area using the trapezium rule, then we have to divide the area under the curve into a number of strips, and these strips must have equal width. The equal width is from here up to there, from there up to there, from there up to there. Those are the width I mean when I talk about these distances must be equal for all the strips. And then you realize that the top edge of each strip has to be replaced by a straight line, so the strips become trapezia. As you can see, it is a curve, but if we are to use the trapezium rule, then we make sure that it is straight and it looks like that one. The total area of the trapezia gives an approximation to the area under the curve. This formula will always be used to get an approximation of the area. That means if you want the exact area, then you use the formula for integration, which is from calculus. But here, if you're using the trapezium rule, then the area you'll get will be an approximation of the actual area. Y naught is the first value for the y. This first vertical line is represented by y naught. The second one is y1. The third one, y2. So these vertical lines are y values, and the width will be represented by h, as you can see. The formula for finding the area for a trapezium is going to be this. We all know this, that when you have a trapezium, to get its area, you just add the short side plus the long side. You multiply them by a half and then multiply by the height. H seems a strange letter to use for width, but it is always used in the trapezium rule. So as we call this distance width, you will have to bear it in mind that it is width, but the letter we are using is h for that width, and we shall see how we'll be calculating the h. We're going to use a real curve. We are going to use a real curve to derive the trapezium rule. We have our curve here. As you can see, when we plot this curve, we get that on the graph. And you realize that if we are to get the area using the trapezium rule, we just have to divide this curve into different strips. But here they said we must use 5 strips. So if we are to use 5 strips, that means we divide this area into 1, 2, 3, 4, 5 strips only. And then if we are to get the area for each strip, for the first strip, for example, it will be a half into y naught plus y1 times h. You see, y naught is the long side, y1 is the short side, and h is the width, which we said is strange for width. So how do we know that our h is 0.2? For example, in this case, you realize that to get h, we get the upper limit. In this case, our upper limit is here, which is 1. We subtract there the lower limit, which is here, which is 0. Then we divide by the number of strips, which is 5. And in that case, when we do that, we get 0.2. So that's why you see all these widths have 0.2. So if we get the area, I think we have already seen this. For the second strip, it will be this one. And when we sum all of them, then there we shall get the approximation of the area. Let's see how we sum them. You realize that the total area will be 1/2 into y0 plus y1 times h. This one is for the first strip. Then this one will be for the second strip. Then in the middle we have some 2 other strips. Then this is the last strip. When you carefully look at these y values, you realize that y0 appears once here. y1 appears in the formula for area 1 and also appears in the formula for area 2. So you realize that y1 appears twice, and y2 will also appear twice, y3 will appear twice, except for the last y, because it appears only in the formula for the last strip. So since y1 is the side of 2 trapezia, it occurs twice in the formula. The same is true for y2 to y4. Finally, your formula for only these 5 strips will look like that. So you'll have y0 appearing once, y5 appearing once, but the middle values, they have to be multiplied by 2 because they appear twice. And you realize that here we are using approximation to the area, because if you use equal signs, that means you're getting exact area, but we have to use approximation symbols since the area is not exact. And then here we have quoted our formula, as you can see, and in this part here we have calculated h. We have said h is equal to b minus a out of n, where b is the upper limit, a is the lower limit, and then n is the number of strips. Sometimes they may give you ordinates in a question. So how do you differentiate ordinates from strips? Ordinates are the vertical values. For example, when you look at this is one ordinate, another ordinate, another ordinate, another ordinate, another ordinate, another ordinate. Then these are strips. So you can differentiate them now. These are strips, but then the vertical lines are ordinates. Strips are the same as sub-intervals, but ordinates are ordinates. So here our strips were 5, that's why we divided by 5, and our upper limit was 1 and our lower limit was 0. So finally we got our h as 0.2. So to simplify the work, we use a table. And we put n in the first column. We put xn in the second column. Then the extreme values are the first and the last, we put them also in their own column, and then the middle values, we put them in their own column. You realize that this n, in short, it stands for the number of ordinates. When we have 5 strips, for example here, 1, 2, 3, 4, 5. These are 5 strips. You realize that we have 6 ordinates. 1, 2, 3, 4, 5, 6. So ordinates are always greater than the strips by 1. So this n stands for the number of ordinates. It doesn't take any mark, but it is useful because it guides you as you calculate these values. H always takes a mark. If you miss H, then you'll miss a mark. So always be careful. Xn, and you see Xn will always, X will always take up the values of this N. We shall have X0, X1, X2, X3, X4, and X5. When we go back to our curve, this point here will be our X0, this will be our X1, this will be our X2, this will be our X3, X4, X5. So our X0 is 0, but our X1 is 0.2. So we keep adding 0.2 until we get to the last value, which is the maximum, the upper limit. So that's why you see here we have X0 as 0, then we add our width, which is 0.2, and we continue adding the same width until we reach the upper limit. So you realize that after getting your X values, then you can use these X values to get the Y values because you have the function. So you're going to substitute this X value in this function to get this Y value. You get this X value, substitute it in this function, and you get the Y value. So when you get 0 and substitute it here, you'll get 1. When you get 0.2, substitute it here, you'll get 0.9615. You substitute 0.4, you'll get that. You substitute 0.6, you'll get that. 0.8, you'll get that, and 1, you'll get that. So you realize that Y0 and Y5 are in the same column, but one is at the first is in the first row and the last one is in the last row, and then these middle values are in the middle also. So after doing that, we sum them and get the total. 1 plus 0.5, we shall get 1.5, and then when we sum these ones, we shall get 3.1687. We sum these middle values alone because we said they appear twice, so we can multiply their sum by 2. And then these extreme values, we don't have to multiply their sum by 2. So when we go in our formula, we just substitute. Our formula was having an H, and this 0.2 is our H, then Y0, Y5, then into 2 into Y1 plus Y2 plus Y3 plus Y4. So you realize that when we summed the first and the last values, they gave us 1.5. As you can see, we have 1.5. Then the middle values, they gave us 3.1687. That's why you see this, and we are multiplying these middle values by 2. So finally, we get 0.78423 significant figures. One point you must note: when they say put your answer to 3 significant figures, you must never use 3 significant figures in your calculations. For example, you realize that here I was calculating using 4 significant figures, meaning if you are to put your answer to significant figures, then in your calculations you use 4 significant figures, except where they are exact values. For example, here this is 1, it's exact. Even if I put a 0, it doesn't change, it will not change the 1. But here, removing 5 will change this value and will change even the total. So when they say put your answer to 2 decimal places, you make sure you use greater than 2 decimal places, otherwise you lose marks. The general formula for the trapezium rule is finally this one. So in our first case, where we had an example, our A was 0, our B was 1, our H was 0.2, our Y0, we got it, we saw this Y0 was the first line, the first vertical line, and our yn was y5, the last vertical line. Then this yn minus 1 was y4. When you get 5 minus 1, you will get 4. So I think you can relate this formula to the formula we derived in here, this one here. So this one had 5 strips, but this one is a general formula for any number of strips. They can be 5, they can be 6, they can be 7, they can be 8. You just need to know that if the strips are 8, you put your 8 here. Then this will be 8 minus 1. Then others remain the same. So where n is the number of strips and the y values are called ordinates. I think I've already told you about ordinates. There is always one more ordinate than the number of strips, because we said ordinates are the vertical lines, the y values. Then the width h of each strip is given by b minus a out of n. And I've told you to improve your accuracy, you just need to use more strips. Here we have another example, which is a trigonometric function, and we are integrating it from 0 up to pi. We are not going to use integration because we are not interested in the exact value, but they are saying that we use the trapezium rule with 6 strips. So that means our last y will be y6 and our first y will be y0. Then the middle values y1, 2, 3, 4, 5, they will have to be multiplied by 2. So when you meet such a question, the first thing to do is calculate h, and here you will get your bonus 1 for calculating h. And then here you realize that our upper limit is pi and our lower limit is 0, and the number of strips is 6, and we shall get pi out of 6. You should always remember to put your calculator in radians when you are using pi as 3.14 because it is a small angle. And always write this h in fraction if it doesn't give you exact values. For example, you realize in example 1 our h was equal to 0.2. We were using it in decimals because it was giving us an exact value of 0.2. But if it gives you recurring values like decimals that are continuing, then there you don't have to round it off. You will lose the mark. So if it is exact, it is fine, you can use it as a decimal, but if it is not exact, like in this case, you have to use it as a fraction. So after calculating the h value, then there you can continue. This is our general formula for this specific example. We have 6 strips, so the last y will be y6, the first will be y0, then the otherwise will be multiplied by 2, and they will be in the middle. To make sure that we have the required accuracy, we must use at least one more dp. I think I've already talked about that. We must have one more dp than the answer requires. It is better still to store the values in the calculator's memories. So this here is our h. So we can now draw the table. These ones here, you can see there are 7 ordinates. 1, 2, 3, 4, 5, 6, 7. There are 7 ordinates. Then you realize that when you have n is equal to 0, you will get x0. Then for n equal to 1, you will get x1. We said these are width. So you will add these width until you reach your upper limit. Our lower limit was 0 and our upper limit is pi, and we have 6 strips. So when we add pi out of 6, add their pi out of 6, add their pi out of 6, we continuously get these values. So we said your table will have 4 columns. The first one is n, the second one is xn, the third one is for the extreme values, then the last one is for the middle y values. So when you substitute 0 in our function sine of x, we shall get a 0. That's why you see a 0 here. And then for the last one, our x value is pi. When you substitute pi, sine of pi will give you a 0 also. That is sine of 180. If you're using your calculator, don't when you're putting pi as 3.1 for the pi on your calculator, remember to put your calculator in radians. Then when you put pi out of 6, sine of pi out of 6, you'll get that. When you put this, you get that. You put that, you get 1. Put that, you get that. Put that, you get that. Then you sum all of them. For the extreme values, you'll get 0. Then for the middle values, you'll get that. When you put in your trapezium formula, your h is pi out of 6, and your extreme values, y0 and y6, you'll get a 0. Then the middle values, they gave us 3.732, and we multiply them by 2. Finally, we will have 1.95. You realize that we have been using greater than 2 decimal places, as you can see. In here, we have been using actually 4 decimal places. So the exact value, this is another question, the exact value of sine of x dx from 0 up to pi is 2. Then the percentage error in our answer is found as follows. This question sometimes is accompanied by part B, which asks you to find the exact area. For me here, I just gave you the exact area, but they may tell you to use the calculus method to find the exact area. You just integrate sine of x from 0 up to pi with respect to x, and you get that area. So here they have given us the value of sine of x from 0 up to pi, that it is 2, and here we can get the percentage error from error out of the exact value. So what is the error? I want you to take an example. If the exact area is 2 and we have 1.92 as the area we calculated from the trapezium rule, then that means there is an error in our area. So this brings us to the formula that the error is always got from exact value minus the approximate value, but remember to take the magnitude symbols. So you get the exact minus the approximate that you got, then you'll get your error. Then you divide that by the exact value. This formula is used here in the trapezium rule, where you say that your percentage error is exact minus approximate. Don't forget the magnitude symbols, then divide by exact. In the error analysis, we will not use exact, but rather here we will be dividing by approximate or working value. You have to note that this formula works here in the trapezium rule. And then when we get to minus 1.95, it must be a positive, because these areas, the exact at times can be smaller than the approximate. That is when you over approximate, and sometimes it can be bigger than the approximate when you underestimate. So in this case, we underestimated. Because of underestimation, we got our exact value is bigger than the approximate value, and our percentage error will be 2.5. So 2 minus 1.95, you will get some answer which is like 0.05, and then divide it by 2, multiply by 100, you'll get 2.5%. In summary, the trapezium law for estimating an area is given by this. You'll find this in your logbooks, where n is the number of strips, the width h of each strip is given by b minus a out of n, where b is the upper limit and a is the lower limit, n is the number of strips. The number of ordinates is 1 more than the number of strips. The trapezium law underestimates the area of the tops of the trapezia. The trapezium law underestimates the area if the tops of the trapezia lie under the curve, and overestimates the area if the tops lie above the curve. This curve here, you realize that it underestimates the area, because you see this curve is supposed to be passing around there, but when we draw our line, we draw it under the curve. That means the area we get under here is smaller than the exact area. So when the line is drawn inside the curve, it underestimates. And when the line is drawn above the curve, for example, like here, we are likely to draw our line above the curve. Then in that case, we overestimate the area. So here you have your exercise. They say use the trapezium rule to estimate the areas of the given, given by the integrals, giving the answers to 3 significant figures. You must note that when they say 3 significant figures, you must use big greater than 3 significant figures, and they have said use 4 strips. And then they're asking you, how can your answer be improved? One thing I must tell you about this is, when they ask you this question, how can your answer be improved? In here, you'll have to say by using you must say by increasing the number of strips, because the question is talking about strips. When the question talks about ordinates like this one, and they ask you how you can improve your answer, then you have to say by increasing the number of ordinates. That's all. So you'll try out these questions. You can pause the video now and try them out and see if you get the answers. The answers are here, so you can pause the video and see what you got, if it corresponds to what is here, and finally this will be your answer. That is solution to question 2, solution to question 2 still, and then this is the percentage error. Oh, it has been a long journey with you. Thank you for watching. We meet when God allows.